Welcome to the Databricks Skill Builder series. We're glad you're here.
Awesome. Thank you, Stephanie. Hey, everyone. This is PJ, and I am a senior solutions engineer at Databricks. I've been at Databricks for the past couple of years now. And yeah, today we are going to cover some of the basics around cluster management and best practices. Just, things to keep in mind while you're creating clusters and some of the good stuff. Awesome. So this is the high-level agenda that some of the things that we're going to cover today. We're going to start off with the Databricks architecture, make sure we set some ground, understand what the Databricks architecture is going into clusters. And then we'll talk about cluster governance, how to create cluster policies, what's the benefit of policies? Should you have them? Should you not? What should be our governance strategy around that? And then we'll continue with some of the cluster configuration steps. So we'll talk through some of the options available to you at the time of cluster creation. And then we'll discuss some best practices. And then towards the end, we'll also do a UI walkthrough in the Databricks workspace, showing you around the cluster manager and the things that we'll cover during the session today. Awesome. Sweet. So before we get right into the architecture, just want to do sort of a quick sanity check. So this is essentially creating clusters obviously depends on a variety of factors, right? And just want to remind folks of the fact that it really depends on your use case and business requirements. So it might be certain SLAs, your use case type or user type, how many people are using the cluster, is this an automated job? And it'll really differ whether you're building either machine learning models, streaming data, and also depending on the quantity of data that you're ingesting or analyzing. And also the aspect here is the budget, how much do you need to spend on your clusters. So for this session, we will focus on some of the general best practices and things to know as you're starting up on Databricks, or if you've been using Databricks for a while. But the idea is that there can be a variety of ways. There might be some set of best practices that work for one team that might not be the best practice for another. So just wanted to call that out and make sure that everyone understands this, as every use case is different. Awesome. But yeah, so some of the things that we'll cover today will be based on some of the general recommendations and best practices when it comes to clusters. Okay, so with that, I'm going to dive into architecture, and this is just to set up some ground, make sure that everyone understands clusters and how to configure them. Just taking a quick look at the Databricks architecture. So the first aspect of the architecture is the control plane, right? So the control plane essentially consists of all of the backend services that Databricks uses and manages in its own cloud account, right? So, and that cloud account is basically aligned with the cloud service in use by the customer. So it might be AWS, Azure, or GCP. And the majority of your data does not live here. Your data is in your customer, in your cloud account, which is the customer cloud account, which we'll discuss in a while. But some of the aspects or elements that control plane does store is, things like notebook commands, workspace configurations, and all of these are encrypted at rest, right? And through the control plane and, its associated UI or APIs that it provides, you can basically do things like launching clusters. You can start jobs, schedule your jobs, interact with your table metadata, cluster management, and all of those things. Now, on the other hand, is the data plane, is where your data is processed and stored, right? So following the classic data plane model, all compute resources in the data plane reside in your own cloud account, right? So data plane basically hosts things like compute resources, right? So for your clusters, they spin up in your environment. And you also have the option to connect to your data store via your data plane. So you might have your data in AWS S3 or Azure Blob Storage or UCS, right? So you can connect to any of those services via your data plane, or which is also backed by DBFS, which is the Databricks file system, which is like just an abstraction layer on top of your data store. And for you to be able to quickly access things from your data store within the Databricks environment. And then you also have the option to provide connections to external data sources from your data plane. And either this can be within your same cloud account, or it might be elsewhere on the internet. So for example, there might be some other SQL data sources that you want to connect via JDBC, and all of those things. So all of those things are connected to your data plane. And the Databricks control plane is, basically manages your account level metadata, right? So you're managing your account, and your clusters. And you as a user, essentially, when you log into the web app, which is a Databricks platform, you basically have, as soon as you log in, you have, different, the web application has different services catering to specific needs of different personas within your data team, right? So there's a data science and engineering workspace, there's a Databricks machine learning workspace, and then the third one is a Databricks SQL workspace. And another thing that control plane has is the Databricks notebooks, obviously. So Databricks notebooks, and or where you can where you do all the development. And there's also repos. So you have the option to integrate any of the uh, tools that you use to manage your version control your code, like GitHub or any other Bitbucket or any of those services that you have the option to integrate as well within Databricks. And then jobs, obviously you can schedule jobs. There's a cron job scheduler that helps you schedule jobs, build workflows, jobs that are dependent on, some other workloads. Those and all, those are all that can be scheduled within the Databricks environment. And this is not what we focus majority of the time today, but there's tons of information on Databricks Academy and docs that can help you set this up. But today we'll dive more into clusters, and we'll talk more about cluster management. Awesome. So just to start with some of the basics around what clusters are. So essentially, clusters consist of a set of one or more virtual machine instances over which your computation workloads are distributed, right? And in the typical case, a cluster has a driver node alongside one or more worker nodes, right? So Databricks can also provide a single node model, but that's typically limited to development or testing environments with really small workloads, right? And in general, your workloads are distributed across all of the available worker nodes by the driver. So essentially, the driver program or the driver node takes care of the job execution within the cluster. It's the node that's primarily responsible to distribute the tasks amongst the worker nodes. And then worker nodes are the nodes that are responsible to basically execute all of these tasks and return those results of the tasks back to the driver. So yeah, this is just another way of representing, how the Spark driver distributes the workloads amongst various workers. We have a Spark driver, which is a virtual machine, and then it distributes the work to different workers to run your, jobs and notebooks. And the third thing here is managed clusters. So we talked about, what a cluster is, and then what a managed cluster is essentially where you don't really need to take care of, the infrastructure behind spinning up the clusters, right? So you can essentially, you're able to create a cluster using the cluster's UI, or CLI, or even REST API, right? So the cluster manager, which is in the control plane, will request to virtual machines, which will request VMs or EC2 instances for your cluster and launch them in your data plane, where your data will be processed. So after your cluster is created, you can use it to run either interactive workloads by attaching notebooks. You can basically attach these running clusters to notebooks and then execute commands. As simple as that. But when it's a managed cluster, it's entirely managed by by Databricks in the backend. All you have to do is just configure it as per your needs, and you'll have a cluster that will be available and ready to use. Awesome. So with that, so a quick reminder here, and there are actually a few different ways of using Databricks clusters, right? So there's not just one cluster. So there's an all-purpose compute cluster. There's jobs compute, and then there's also SQL compute, right? So all-purpose compute, this is which is essentially a cluster that is used for more ad hoc analytics types of workloads, right? So any development work ongoing development that you're doing, it's preferred that you use an all-purpose cluster. And then jobs compute is an ephemeral cluster, on the other hand, which essentially means that when you run a scheduled job, so it starts and ends at specific times when that job is complete. So in a sense, it starts when the job is scheduled for, and it terminates itself as and when the job is completed. And then the third is your SQL compute or SQL warehouse, right? This is essentially a computation resource that lets you run SQL commands on data objects within the Databricks environment, right? And you can also see there are different types of SQL warehouses, but we won't be discussing that in detail today. But for your knowledge, there's a classic SQL warehouse, there's serverless, and then there's ProSQL warehouse. And then just to have a quick summary, so there's one thing to remember is that the jobs cluster is really for your production repeat workloads, right? Or maybe a single user that is scheduling and repeating the job, and it's cheaper as a computation resource on Databricks, right? I think the cost difference is at least a two to three times lower than an all-purpose compute. So if you know that your job is repetitive, or that's something that needs to be run on a daily basis or on a different schedule, make sure you're using a job cluster instead of all-purpose cluster, because that's another one of the best practices that's recommended, because it'll obviously save you costs and it will avoid any hindrance, because that cluster will be dedicated to to your job. And essentially an all-purpose cluster, on the other hand, as I mentioned, is useful for ad hoc workloads. If there's multiple users using the same cluster, doing some EDA on the data. It is slightly more expensive than job clusters, but it's very convenient when you've got a lot of users wanting to use that compute resource at the same time. So that's basically a development cluster. And as for the SQL endpoint, just to quickly mention here, SQL warehouse. This is essentially for dashboarding or BI reporting or running queries. So when you're in the Databricks SQL persona, you have a SQL editor, right? So to execute any of those queries, to run those queries, and even to build dashboards in the persona, the SQL warehouse or the SQL compute is what you will use. Awesome. And as Stephanie mentioned in the beginning, feel free to type in your questions in the Q&A, and we'll make sure we answer those. Awesome. So the next thing I want to cover is cluster governance, right? So there's really different ways to govern your cluster. The focus here would be to let you guys know what are the different approaches and what are the different ways that we've seen that people govern their clusters, right? So there's really three main ways that you can approach it, and by this I don't mean all of these three ways are correct. It might be right for someone, it might not be, and some of these are recommended, and some of these are maybe not so recommended. But all in all, these are the three ways that you can approach for managing clusters and their associated cost. And again, each of which has it presents a trade-off between cost control and the overall effort required to set up and maintain these clusters. So talking a little bit in detail about these approaches. So the first option is to provide users with the unrestricted ability to create and manage their own clusters, which is definitely not recommended, especially for companies where there's multiple users on Databricks, right? Even though this is a very easy measure to implement and super convenient, it gives users a high degree of latitude and makes it really impossible to control your costs related to compute resources, right? So if essentially you're giving free access to every user on Databricks to spin up as big a cluster they want, and that really won't be helpful when you're trying to keep everything budgeted and everything in control of what resources we're letting the user spin up. So this approach might not be appropriate in most settings, and it's generally not recommended to do. The second here is it's really the opposite end of the spectrum, is that users are prohibited from creating clusters altogether. So instead, you have workspace admins within the company who create clusters on behalf of these users or service principals that need them, and then they grant access accordingly, right? Even though this approach provides the highest degree of cost control, but it really requires an ongoing process that requires some effort from the admin side to maintain. And it also introduces some potential delays and especially some frustrations, especially if the workspace admins they aren't available to create resources when needed. So really the recommended approach is the third one, so which is sort of a compromise between these two extremes. And here there's also something called as cluster policies that come into play. So cluster policies really allow admins to essentially define rules that allow users or service principals or IAM roles to create their own clusters subject to restrictions that are set out in that particular policy, right? And once you set up a cluster policy and you assign users to it, all the user has to do is select the cluster policy once they're trying to create a cluster, and they will only have access to certain attributes and limited control over for example, how big of a worker can they choose? Is that something that's restricted by that particular policy? So they won't be able to spin up a larger cluster than what's been set in the policy. So really this is like one of the better ways to not even just control cost, but also to make it much more easier for the users to gain access to that computation resource without having to worry about budget or making sure that the admin is available. So once these policies are set, users can create or spin up their own clusters. Awesome. So we will dive into cluster policies a bit and see how they're set up. But before that, so another thing here is cluster access control, right? So there's different types of permissions and different levels of permissions that you can provide to users for a specific cluster, right? So obviously the first one being no permissions. The second, the first relevant permission here is can attach to, right? So can attach to is essentially when a user is able to attach this cluster to a specific notebook. And by that I mean the user can only attach a running cluster, right? So they won't have the ability to start or restart a cluster. They just have the ability to attach a running cluster to a specific notebook for development. And any user with the can restart permission is essentially able to also attach the cluster, but they can also start a terminated cluster, right? So if a cluster has been terminated and they wanted to want that cluster to for their computation of the notebook to run the notebook, they're able to start that terminated cluster or even restart the cluster if there's any issues. And then finally, there's the can manage permission, which is essentially, you can manage the entire cluster, right? So you can edit the cluster configuration. You can attach a library, like a third-party library, to a particular cluster, or you can resize it and change permissions, and grant access to other users, whether they can either attach to or restart the clusters. So these are the three main access controls that need to keep in mind when you're providing access to access of clusters to these to your users. Awesome. So let's talk about cluster policies, right? So as an admin, you can configure cluster policies to limit what attributes or attribute values are available for cluster creation, as I mentioned, right? So users can then, they just need to select a cluster policy from the policy dropdown on which is on the cluster configurations page. And we will see all of that in a UI or in a demo in a short while as well. But the idea is you can configure these access controls that limit cluster policies to specific users and groups, right? So if you have a group of users or a team of users within Databricks, you can provide or assign those groups to these cluster policies for that particular group of users. So the idea is that cluster policies allow you to limit users to create clusters with a set of prescribed settings. They also simplify the user interface by either fixing or hiding some values to enable more users to create their clusters. And this also allows you to control costs by limiting the per cluster maximum cost. For example, you can set limits on attributes whose values contribute to your hourly price, right? So in this particular example on the slide, so there's a policy that allows you to allows users to create a medium-sized cluster with minimal configuration, right? Really, the only field required at the time of creation is a cluster name. The rest is fixed and hidden, right? And the view on the right is what you can see is what the user will see once they have this medium-sized policy. And on the left is the actual JSON configuration of that particular policy. And this is where the admins would configure and decide what attributes are to be shown and what attributes to be restricted. And on the right is what the user would see, right? And one thing to mention here is only admin users can create or edit these cluster policies. And also admins do have access to all of the policies, so they have unrestricted access to the clusters. So what really are the benefits? Well, some of these things I've already mentioned, being able to control costs, preventing unnecessary large clusters with high workers. It also improves your governance. You can enforce something called as cluster tags, and we will dive into that a bit. But essentially, you can enforce cluster tags for cost analysis. All in all, it minimizes the disruption once there's correct limitations in place from day one, as more and more users are onboarded. Even if there's a new team member that is joining your team, it's easier to have these cluster policies all in place, and all you have to do is assign those to the user without having to worry about onboard or enable that new user with all of these restrictions. So the third thing here I want to mention is personal compute. So the personal compute is a new Databricks managed default cluster policy that is available on all of the Databricks workspaces, right? So this policy really just allows users to create a single machine compute resources for their individual use, so that they can start running workloads immediately, and while at the same time minimizing that compute management overhead. So personal compute resources are essentially all-purpose clusters, right? And the properties that it has is they are single node clusters, right? So this is clusters with no workers. There's just one node, which is a driver node that's running everything. And they use the single user cluster access mode, and is also Unity catalog capable, which is the Databricks governance data catalog. The runtime is in this is set to use the latest version of the Databricks runtime. And in case you're wondering what runtime is, we'll touch upon that in a bit as well. Oops. So yeah, and the last thing is auto termination here is disabled. So you have to make sure that you terminate the cluster when you're not using it. But really, the idea behind this is just to be able to provide you with a really basic cluster in case you're stuck somewhere, or you're waiting for access, or things like that. But you really need some compute to excuse me. Sorry about that. But yeah, so this is the idea is just to make sure that you have something to uh, run across your workloads while you're waiting access, or if it's just a really small workload, that in those cases, this personal compute can come in handy as well. Awesome. So the next thing is Databricks tags, right? So I touched upon a little bit, but essentially, so Databricks tags allow you to monitor your cost and accurately attribute your consumption to your company's business units and different teams. So for things like chargeback analysis, you can tag workspaces, or you can even tag clusters, or you can even tag your cluster pools, right? So essentially, it helps you do the chargeback analysis. So if you, let's say you're working on a project, right? So you have, let's say, 5 to 10 people working on a project. All of those, any of the new clusters that you spin up for that particular project, you can tag that to a specific project, right? So let's say you spin up 15 clusters for a particular project, and all of those 15 clusters will be tagged with this project. And when you get your usage report, yeah, it'll have a proper segregation of how many, or what was the exact consumption for this particular project because of those tags. So essentially, they just allow you to navigate and keep a check on how much each project or each team is consuming.
Hey, PJ, we got a question.
Mhm.
The question is, how do we determine the termination time?
Yeah, that's a great question. So by default, and this is something we'll touch upon in a bit. Let me skip to that real quick. Uh, uh, Sorry, there's so much here. Yeah, so auto termination. So as you see on the right in the screenshot, right? So you have an option where you can automatically terminate your cluster after certain minutes of inactivity, right? So by default, I think it's set to 120, but you need to make sure that you check mark this box, because if you end up not checking this box, your cluster is essentially running forever until you manually go and terminate it. Right. So yeah, this is another best practice and a good point brought up, that you need to make sure that you're terminating you have your auto termination on for the cluster, because it's another measure that will help you keep your costs under control, because for anytime that the cluster is running, you are consuming DBUs, which is Databricks units. So you are paying for the time that the cluster is being spun up, right? So yeah, this is where the cluster manager, and we'll see in the demo as well, where you can change this auto termination time. But yeah, this is where you go to check that. Hope that answers your question. Awesome. So let me go back to this. Okay. Can you guys, Stephanie, do you guys still see my screen? Oh,
I did, and now it's gone.
let me share this again.
Oh, so I think the question was misunderstood. He's looking to understand how do you calculate the duration of the termination time? So I'm going like, what's the recommendation, I guess, for how long we should set the termination time to?
So just to make sure I understand, so the question is to provide a recommendation on how long the auto termination time should be.
Yes.
Okay. Yeah, so I would say ideally, it really depends on how many users you have aligned to be able to use that cluster, right? So if it's an all-purpose cluster, it is an all-purpose cluster. Ideally, I like setting my cluster time auto termination to 60 minutes, right? So if my cluster is inactive for more than 60 minutes, it'll terminate itself, right? But I have seen a lot of customers who set that time to like 120 minutes, which just make sure that if anyone else is using the cluster, um, that they have enough time to query, because anytime you spin up an all-purpose cluster which is not serverless, it will take around 3 to 4 minutes to spin that cluster up, right? So to avoid that, a lot of folks try to keep it to 120 minutes, but it really just depends on what your level of comfort is. And if you have let's say five folks working 9 a.m. to 5 p.m. on a specific project, then if they're actively working on it, then there's doesn't really matter. But in that case, you can set your auto termination to be anywhere between 60 to 120 minutes. That's really mostly what I've seen.
Great. Thank you.
Yeah. Awesome. Good question. So yeah, as I mentioned, cluster tags, and we will see this in the demo, how you can where to set up these tags. But essentially, these are just key value pairs, right? So you mention let's say a project, and then the project name, and then in the cluster manager, this is where you actually use cluster tags, right? I think that this is an old screenshot, that the new UI is a bit different, where you have the option to add tags above the advanced options, but we will see that in the demo. Awesome. So just a quick recap, things that we recommend around cluster governance. What are the best practices? So the first best practice is to restrict the cluster creation access across all of your users, right? Because you want to make sure that you have an admin that controls which clusters can be spun up, and really just controls the cost and policies around that. Excuse me. And then you will apply these restrictions to users, so that they don't have free for all spinning up clusters here and there and consuming DBUs, which just translates into higher cost. So first, you always restrict the cluster creation, and then you can further fine grain it. You can give users cluster rights or access control. So going back to the can attach to, or can restart, or can manage permissions. And then you can also assign cluster policies, right? So assign cluster policies to restrict who can spin up certain types of clusters or instances across the workspace. Make sure you assign a policy, and that your users only have access to that policy. Make sure to use cluster tags to control cluster costs, and also attribute your cost in your workspace in AWS or Azure. Awesome. So the next aspect I want to focus on is cluster configuration, right? So again, there's also different modes to when you try to when you start up a cluster, right? So you have different access modes, um, and it primarily specifies whether or not the cluster can be shared, and has implications on the functionality that is supported by the cluster. So there's three different access modes: so single user, shared, and no isolation shared. So the single user, as the name suggests, it's clusters that that use this mode can only be used by a single user who is designated when the user created that cluster, or while editing the cluster, and others will not be able to attach their notebooks to this cluster regardless of any of the cluster permission settings. So the single user restriction is in place because the cluster supports features that would make it difficult to provide true isolation at the user level. So some of these features, like init scripts, any third-party library installation, or DBFS mounts. So in terms of language support, single user cluster support all the languages that are available on the platform, which is Python, R, Scala, and SQL. And then the second part is second access mode. Apologies, is shared clusters. So these clusters can be shared by multiple users. So if you have multiple users that are sharing a common cluster, um, they can be this is the access mode that you want to select. The languages it supports is SQL and Python. But the advanced cluster features mentioned earlier are not supported. The third one is here is no isolation shared, right? So this is an option for legacy support, and it does not support UC, which is the Unity catalog. So for new clusters, it's generally not recommended to use this access mode unless there's a really specific need. Cool. So the next is Databricks runtime. So one thing I want to mention here is, so I mentioned this a little while earlier around runtime, but Databricks runtime is essentially a collection of core software components that are running on the clusters of these virtual machines that are managed by Databricks, right? So it includes Spark, but also adds a number of components and updates that substantially improve the usability, the performance, and also the security of your workloads, or of the cluster workloads running on your cluster. There's also an add-on called Photon for optimizing performance and cost, right? And we will we won't go into too much detail around Photon in this particular session, but it's essentially a Databricks Databricks built vectorized engine that is built on C++. And it accelerates your workloads and dramatically increases the performance of your workloads. And Databricks also offers an augmented runtime that is more catered towards the needs of machine learning workloads. So it basically adds all of the popular machine learning libraries that are typically used for machine learning, like TensorFlow, Keras, PyTorch, XGBoost, LightGBM, Scikit-learn, and all of those things. So all of those libraries come pre-packaged within the runtime. And as I mentioned, Photon dramatically speeds up your query engine with literally zero tuning or setup. It is only available on Databricks. And apart from the fast query performance, there's really no code changes that you need to do. It's as simple as just turning on Photon when you're configuring your cluster. And it is, since it's compatible with Spark and its APIs, meaning that existing code works as is. There's no really extra code changes that you need to do to get Photon up and running. Okay, so the next is node configuration. So these are So yeah, I think this is something that we've already discussed. Here it also mentions high concurrency, but that's been now deprecated with the introduction of Unity Catalog. But again, the idea is, running single node with cluster. Again, there's only one VM instance, and then the multi-node is default mode for workloads that can be developed in any of the supported languages. So again, these are some of the common instance types. This is specifically for Azure, but there's different for AWS and GCP. But really the key thing to focus on here is on the extreme left column, which is the workload types, right? So and this is something that really depends on what type of workload you're running on this cluster, right? So if your job is slightly more memory intensive, just make sure that you select a memory optimized cluster or memory optimized worker from the list of worker and driver nodes that will be there in the cluster manager, right? And then there's similarly compute optimized. So if your job is compute heavy, then and this mostly conforms to a lot of machine learning models as well, right? So if you're building a model that uses a lot of memory, then memory optimized uses a lot of compute. It's compute optimized. And then if you know that you're dealing with a really big amount of data, and there's a lot of input, output, and read write operations involved, then storage optimized workload type is more recommended. And then there's also general purpose workload type, which is essentially for just basic maintenance jobs, right? So if you're running things like an optimized job or a Z order or something like that. Awesome. So the next thing here is spot instances, right? So for folks who already understand, what spot instances are, so it's pretty straightforward. But for the people who are, new to it or understand it a bit, essentially, and I'll take an example of AWS in here. So AWS has two tiers of EC2 instances, right? So one is on demand and the other one is spot. So for on-demand instances, you pay for the compute capacity by second with really no long-term commitments. However, spot instances allow you to use some of the spare Amazon EC2 computing capacity, and you're able to choose the maximum price that you're willing to pay. Right. So spot pricing changes in real time, really just based on the supply and demand on the AWS compute capacity. And if the current spot price is above the max spot price that you're willing to pay, the spot instances are automatically terminated and they're converted to on demand automatically, making sure that your job doesn't fail, right? So one of the best practices in here is don't use this in production, right? Especially if it's a sensitive job. And also make sure that you have at least one or two is recommended, two nodes as on demand, and then the rest can be followed by spot instances, right? And this really makes sure that even if your spot instances fail, your job will have something to fall back to, because spot instances, it's not uncommon for spot instances to fail, right? So in that case, if you have one or two on-demand instances, at least for the driver, it won't fail your entire job, and you just wait for some the other spot instances to be converted to on demand before your job gets back to the speed it was working on. So okay, next one is the next one is pools, right? So I did want to talk a bit about instance pools, right? So what is a pool, right? So let's start with the why. So traditionally, if you spin up a cluster, it takes quite a lot of time to acquire that instance, right? Particularly if you are installing, let's say specific libraries and you have dependencies on those libraries, then it can be quite a long process, right? So, and if you have a job that is only a short running job, you might need to wait a long time for the instance to be acquired, to start up, to run, and then terminate. The job itself took like 5 seconds, but it took like 3 to 4 minutes to spin up that instance, right? So to resolve, and for a lot of people that's a problem, right? So to resolve this, this is what you can create, what which is called a pool, right? And this is essentially where you can hold a pool of instances that are ready for use, right? So it essentially holds a warm, ready to use pool of instances, and it dramatically reduces your cluster start and auto scaling times by, as I mentioned, maintaining a set of idle ready to use instances. So when a cluster is attached to a pool, right? So all of the cluster nodes are created using the pool's idle instances instead of freshly spinning them up from AWS or Azure. And if the pool has, let's say, no idle instances, it will expand automatically by allocating a new instance from the instance provider in order to accommodate the cluster's request, right? So when a cluster releases an instance, it essentially returns to the pool and is also free for another cluster to use. So there's nothing really that you need to manage. All you need to is configure. And there are, again, a few other best practices in here, because you have the ability to control over how many idle instances that you want to maintain over a certain period of the day, right? And one of the common things to consider here is, let's say you're working from 9 to 9 a.m. to 5 p.m., right? You know that a lot of your jobs will be running between 9 a.m. to 5 p.m. Then what you can do is you can have a minimum count of idle instances set to, let's say, 5 or maybe less, really depending on your SLAs. But the idea is that the time during which that that jobs are going to run, you can set the minimum idle, minimum number of instances that your pool should hold is a specific number, and after that time you can boil that down to 0, so you don't keep paying extra costs. Because one point to mention here is, even though Databricks doesn't charge you for all of these idle instances, but your cloud provider will, right? So your cloud provider will charge some cost for having these warm instances, ready to use instances being in the idle pool. So yeah, all in all, you can define all of these limits on pools as you based on your workloads, and as long as you wish to hold them. But it is a life changer, and in a lot of cases I've seen where um, you know instance pools have been helpful, and just because it just reduces the cluster startup time and doesn't have to wait for instances to spin up. Awesome. Yeah, I think we pretty much covered this, right? So Databricks does not charge for DBUs for idle instances, but your cloud provider does. Next thing, I know we have about 10 minutes left, so I do want to go into the demo right after this slide. And this is essentially auto scaling, right? So auto scaling is it's essentially, if you enable auto scaling, the cluster dynamically reallocates more worker nodes to your job, and really based on the workload, right? So it'll dynamically reallocate more workers to your job. And the idea essentially is, when you're running a particular job, or even when you're running a workload, certain parts of your pipeline may be more computationally demanding than others, and Databricks automatically adds these additional workers during these phases of your job. And it also removes them when they're no longer needed. So it basically spins the number of workers down, and you have the control on the minimum and maximum number of workers that you want at any time for this particular cluster. Awesome. So with that, I do want to quickly move on to the demo. So let me, Stephanie, can you confirm if the folks can see my demo screen, or this?
I can see your workspace.
Oh, you can see the demo?
Yes.
Okay, perfect. Thank you. Yeah, so this is the Databricks workspace, right? So as soon as you log in, this is where it takes you. The three different personas are here that I was talking about. Uh, and then specifically for clusters, dive into compute. Uh, and then once you go into compute, this is your cluster manager, right? This is where all the fun stuff is. This is where you manage all the compute power. So by default, you're in all-purpose compute, right? So when you try to create an all-purpose compute, let's say create compute, and then the first option is you have the option to select a cluster policy, right? So based on the kind of access that you have to different cluster policies, you'll see that list. And then in this case, there's a demo. For the sake of simplicity, it's all unrestricted, so you see all of the options that are available. So here we have option multi-node and single node. For the most part, you'll be using multi-node because that's where the real power of clusters and distribution is. And then you have the option to select access modes. And again, this is nothing different from what we already discussed in the slide deck. The different access mode. Let's say you want to go for a shared mode. And then you select your Databricks runtime, right? So there's different versions of Databricks runtime, starting from 7.3, it's 13.1 beta. And it really, this is something that keeps on, adding in the Databricks environment. And you also see LTS, some versions with LTS, and LTS means long-term support, right? So these are basically runtimes that will support it for at least, I think it's 2 years, right? So these runtimes will be supported for at least 2 years from now before being deprecated. So essentially the idea is if you're running any of the production workloads, make sure that you run these workloads on one of the LTS versions, because it's just much more stable. And then the beta runtimes, are more experimental, still in the beta stage. So while you can use it to test out your workloads, it's not recommended to use beta runtimes in your production workloads. And similarly, there's a different list of runtimes for machine learning, right? So as I mentioned, machine learning, it's basically a collection of all of the uh, famous machine learning libraries that are used, as I mentioned earlier. And then there's also the option to choose if you want a GPU enabled runtime or not. Really, if, for example, if you're doing a lot of deep learning, this GPU, GPU enabled runtime is what you want to go for. And then there's the option to use Photon. And then you have a list of worker nodes. This is in a AWS environment. So you have all of the AWS instances that that we have available that we can spin up. So one thing you notice here that I mentioned earlier is based on your workload type, make sure that you select either storage optimized, memory optimized, or general purpose clusters. And really the idea is, and this is not something that you'll have to get right. It's just more optimization based on your workload type, right? And if you don't know what type of workload is it storage heavy, memory heavy, there's ways in Databricks that you can figure out. There's metrics you can track. Again, I'm not going to focus on some of the performance stuff here because that's a whole separate session, and we can cover that in another session during the series around performance and optimization. But here the idea is to select the worker type based on the type of workload that you're running. And then we have auto scaling enabled in here. So since we have that enabled, we have the option to choose minimum and maximum workers. And if we, let's say, don't use auto scaling, then we can just say that, hey, we want this cluster to use eight worker nodes at all times, or more or less, right? And then here is the auto termination option. So this is where you can choose to terminate your clusters after X minutes of inactivity. Usually I like it to be set at 60, but it can really vary based on your needs. And then instance profile. So if you're using AWS, you know this. If you want to give this cluster access to certain data, you can have that instance profile set up here from AWS. And then this is where you'll add tags to the cluster, right? Some of the automatically applied tags are really just high level, where we have the username. So essentially the user who spins up this cluster. In this case, it's my name. And then in the advanced options, you have the option to select the number of spot instances you want, right? So general recommendation, having at least 2 driver nodes and at least 2 on-demand nodes for your driver operation, making sure that your job doesn't fail. And also not to use spot instances in your production workloads. And then some of the other properties here are, you can select for the spot instances, you can select the max spot price, and 100 here essentially means as because the pricing for spot instances keep changing, right? So as soon as any spot instance price goes above 100% or reaches 100% of on-demand price, or basically levels the on-demand price, it'll automatically convert that spot instance to an on-demand instance. So, and then you have the option to add additional Spark configuration here if you want. Another thing that I would recommend as a strong best practice is to make sure that you have a logging destination. So this is essentially where your all of your Spark logs will get delivered to. Your cluster logs will get delivered to, and you can choose that location to be probably like an S3 location where your data will persist, right? Because in Databricks, by default, it will log all of your cluster logs, but I think the limit is up to 30 days. Like after 30 days, all of your cluster logs are lost unless you also store it to a destination. So that's why it's recommended as a best practice, making sure that you have a data store where you are storing all of these cluster logs. Awesome. So the last thing here is init scripts, right? So let's say you want an init script essentially is a shell script that runs during startup of each cluster before the driver spins up. So one of the most common tasks that init script is used for is to install some of the packages and libraries that are not included in the Databricks runtime. So you have the ability to even do a small quick pip install in your notebook, which will be sort of like a notebook scope library. But if you want, you have a library that multiple folks will use, you can have that initialized in this particular script. So as soon as any user who's using this cluster and attaching to their notebook will have access to this library, right? And there's a documentation around and in docs.databricks.com around cluster nodes that we will send it to you later, that essentially covers step-by-step process of how you can set it up. But the idea here of init scripts is to be able to use these third-party libraries or your own developed packages. So yeah, I know we are on top of the time. So this is pretty much it about essentially about clusters. So I hope this session was helpful, and we'll send up follow up with some of the material that is relevant around cluster management and best practices. But yeah, hopefully this was helpful, and thank you everyone for joining.